All right. Okay. Mobile installations. If it's going to be a permanent installation, not like Jack's, you need to run a heavy gauge cable up to the battery and make a direct connection to the positive and basically negative terminals of the battery, or to the negative ground chassis connection, where the battery usually has a fairly heavy braided cable to connect it to the chassis ground. I think actually the connection on the battery terminals is preferable. Most of the mobile radios, well, in fact, even the other transceivers, the power cable that comes with them will have fuse in line on both leads. So in the mobile installations, typically you got a fuse on the hot side and the neutral side or ground side. I can't exactly explain the reason for the ground one, but that seems to be the industry standard. Where should the negative power return of a mobile transceiver be connected in a vehicle? Uh, operating from batteries, when we're doing emergency communications type drills and things, we operate off of batteries, either with handhelds or from batteries connected to the radio, maybe being charged by solar cells. You're kind of simulating what would happen if you had a catastrophic power outage. Like we actually get one of those CME events that hits the earth instead of misses it, like what happened last month. When you're operating on batteries, you have to remember that they only hold so much charge. So to figure out how long you can operate, you take the amp hour rating of the battery, okay, and divide it by whatever the average current draw is for your radio. So here you're factoring in duty cycle. So if you were running FT8 at 50% and you're running it at 20 watts, okay, then you'd figure that in the calculation of what your average current would be. It's one of the, maybe the last arithmetic question. How can you determine the length of time that equipment can be powered from a battery?
Watt hours, wouldn't it? Well, that's right. Bill?
Now, come on, Rick.
Oh, big Bravo. Okay.
Bravo. You could use watt hour rating, but you still have to, divide it by the average current draw and do a conversion, because watt hours would be the voltage times the amps hours as opposed to amp hours.
So if you got a battery in watt hours, you can divide by the voltage
Right.
to get your amp hours.
Most of the time, the battery is going to be specified in amp hours or milliamp hours if it's a small one. Okay. Another factor you have to play with is called microphone gain, which is usually an internal setting, at least on a base station. Not sure there is such a thing on a handy talkie.
I don't think so on my
You kind of
mobile.
depends on how far away you hold it. But on a base station, there's an adjustment where you can change the input gain on your audio. If it's set too high, even on voice signals, it can cause distortion. If it's set too low, you're not going to modulate the signal enough, so you have a very weak signal. It's really important to get it set properly on digital modes because it has a bigger effect on those and will cause kind of a clipping effect on the digital signal. Normally, I'd say it's probably set at 20, 30% from what I've seen. That's what I run. Tuning is another feature on the radio, usually a knob, to allow you to set the frequency. In the case of like a transceiver, you'll have a tuning knob someplace that either will adjust the VFO or select a different memory channel depending on what mode you're in. I guess I've never actually seen that, but if you manage to get off frequency a little bit, say you were in VFO mode and you were 5 kilohertz below what you're supposed to be or above, you're going to hear a distorted signal because you're shifted out of the passband like halfway. To set the operating frequency, you can either use the little keypad to select one of the channels or even the VFO frequency. You can rotate the VFO knob, and usually that is the same as selecting a memory channel, depends on which mode you're in. And in most cases with repeaters and things, you're going to have all these memory channels set up for the different repeater frequencies and for simplex frequencies. So you just select those. And in VFO mode, it's not going to have your setting for access tone, CTCSS, or your offset. So when you're dealing with repeaters, I guess you can do it in VFO mode. Can you manually go set those in VFO mode?
Yeah.
Most people just use the digital memory channels.
What did you say? VFO?
Variable frequency oscillator, which
Just
should actually like an analog vary the frequency, whereas the memory channels are set up already for a frequency and an offset and a tone. Another feature that radios have, even a lot of the handy talkies, allows you to do scanning. So you can scan through a range of frequencies just to see if any, just typical radio scanner. See if you hear, and it will, in most cases, stop if it detects a signal, at least pause.
Usually selectable, yeah, to pause and go on if you don't do anything, or to stop and stay there, and you can.
Usually you have 3 settings on that. It'll pause for a second. If you don't take action, it'll continue.
Mhm.
And the next one is, as long as a signal is being transmitted, it'll stay there, but when it quits, it starts again. And the other one is, it just stops where it picks up a signal and stays.
You gotta hit a button to make it scan again, yeah.
So what is the effect of microphone gain on single sideband transmissions?
Bravo.
I clicked the wrong thing. What is the result of tuning an FM receiver above or below a signal's frequency?
Well,
Yeah, actually, since it's FM, it wouldn't change the audio pitch if you were If you're on AM or single sideband and you're off frequency, it changes the audio pitch. You get the Donald Duck or the guy in the rain barrel. Which of the following can be used to enter a transceiver's operating frequency?
Well, it'd be Delta, because all of them we can do, right?
Which one allows you to change the operating frequency?
Alpha.
Right.
You can do all three of those, but you can only do alpha to change the operating frequency.
Yeah, the CTCSS or DTMF doesn't change the frequency. Select it. And automatic frequency control just tries to maintain the frequency that you got selected to keep it from drifting. I'm not sure most handy talkies have AFC. They have gain control. I'm not sure they have automatic frequency control.
And some of them have the gain control. I don't think all of them do, though. I don't think the one I've got does.
What is the way to enable quick access to a favorite frequency or channel on your transceiver? That's what they're there for. What does the scanning function of an FM transceiver do? Another control is called squelch. It's set up so that you can adjust that it turns off or mutes the audio signal at a certain signal level. So if the squelch is all the way down or not on, you'll hear static if there's no signal there. I mean, there's signals, but not the signal you want to listen to. As you adjust it and increase the level to a point where it will mute it, you won't hear the audio, the noise anymore, but you can still hear a signal because its signal level will be above the squelch value. In the case of doing this with FM, if you were trying to say you're doing, well, I guess like this morning's exercise on simplex, if you're trying to listen to somebody who is very, very weak signal down in the noise, okay, you have to basically turn the squelch off to be able to hear them. And then you might be able to hear the signal down there in the noise. Because normally the squelch would be at a level where you wouldn't hear that signal. And in some cases, like in my radio, I can turn the squelch off, but I don't have the squelch adjustment. It's like an automatic squelch. And it automatically adjusts it. So my only option, there's a button on the side to totally disable it. It's either on and automatic or it's off. What is the purpose of a squelch function? How is squelch adjusted so that a weak FM signal can be heard?
I think it'd be alpha, wouldn't it?
Yep. Did you participate in simplex?
Yeah.
I talked to Sam at 9, but
Yeah, I was just,
Steve never showed up.
no, he never did.
Okay. There's also a frequency offset. We usually just call it repeater offset. So when you're dealing with a repeater, you have to remember that you transmit on one frequency and you receive on another. Whereas in simplex mode, you're both transmitting and receiving on the same frequency. So it's like what we used to call half duplex. In repeater mode, and you'll see usually there's a symbol, a DUP, to represent duplex when you're doing a repeater and there's an offset. In the case of 2 meters or VHF, the offset is plus or minus 600 kilohertz. In UHF or 70 centimeters or 23 centimeters, I'm not sure.
But that one either.
It's at least 5. It might be higher than 5. I don't know. But it's, the standard is plus or minus 5 megahertz. Typically it's a plus, but sometimes there'll be one with a negative repeat frequency offset. So when you're on your handy talkie, you're hearing them on the repeater's transmit frequency. Okay. And when you talk, you're talking on the repeater's input frequency. And theirs are either 600 kilohertz or 5 megahertz apart. That's one of the things that you have to program in the radio on that memory channel.
Yeah, GMRS is +5 on this, all of them.
And if you're not, if that's not set right, you're either not going to hear them or they're not going to hear you.
Incidentally, 23, currently 12 megahertz, 20 megahertz.
Okay, well, that figures.
2 different offsets on there.
I haven't tried it. I don't think there's anybody around that runs on that.
I've never seen a 23 centimeter radio.
Oh, I have one,
Oh, you did?
but I've never,
9700.
huh?
The 9700?
Yeah, I've never tried.
Yeah.
Well, I couldn't before.
You have an antenna?
Yeah, I got a
Tri-band?
tri-band antenna.
Alpha.
Alpha. What's meant by repeater offset, right? Okay, so in the mobile situation, you want to try to connect to the battery terminals, or as close as possible. Running on batteries, you can figure out how long you can normally operate by dividing the amp hour rating of the battery by the average current draw for your radio, which should give you the average amount of time you can operate.
Which is usually gonna be 13.8.
Now, yeah, that's kind of a gross, because what happens is when you don't want to operate like a lead acid battery below 12 volts. That starts to hurt the battery. So even though it still has charge in it, you don't have the full, if it's a 12 amp hour rated battery, you don't really have 12 amp hours. You would if you discharge it to 0, but then you probably ruined the battery. Let's see. You need to make sure that your microphone gain isn't too high or too low. Somewhere in the middle. You can start at 50%. It's probably close enough. There's different ways to tune. You can do it from a keypad. You can do it by the VFO knob, or whatever you use to select different memory channels. You can use the scanning function to look for signals over a wide frequency range or memory range. They can usually be set up where you scan over frequencies or you scan over memory channels. The squelch basically is set up to mute the signal or the audio when there's no actual signal present. You can turn it off to listen for a weak signal. Got to remember the frequency offsets or repeaters are either 600 kilohertz or 5 megahertz, depending on its VHF or UHF. Or, well, let's see, 0.3 centimeters is still UHF. So, but that's not an exam, so you don't need to remember that it's 12 megahertz.